Good evening, my fellow scientists. It is Wednesday, August 9th, 2017. I want to talk about an article that came out in the New York Times last week talking about the possibility of a brand new battery technology that's going to solve all of our problems based on alkaline cells that are going to be made rechargeable. The company is Ionic Materials. They are touting their new technology as going to be improved lithium-ion as well as a new form of rechargeable alkaline batteries. It's the rechargeable alkaline battery that makes me excited because that would mean that the price per kilowatt hour would be a lot lower. In terms of energy density, the AA lithium-ion battery is going to hold about the same as a AA alkaline battery. They both are very, very similar, coming in at about 2.5 watt hours per AA cell. But the lithium-ion battery can be recharged many times, whereas the alkaline battery, you have to throw it away and recycle it. So how do alkaline cells work? You start off with some zinc. It's in a metallic form, and the zinc wants to oxidize to zinc 2+. That releases electrons, which go through your device, whatever you're trying to power, but they have to go somewhere, and they're going to reduce manganese oxide. That exists as kind of a paste over on the cathode side of the battery. When that gets reduced, it becomes Mn2O3, and with the help of a little water, releases OH-. Now if we draw this as a classic voltaic cell, you need some kind of salt bridge in order to maintain charge balance, because we're building up these negative charges on the cathode side that you need to balance those out by transferring OH- over to the anode side to complete the circuit and make zinc hydroxide. The point being that if you want to make this rechargeable, you need to have two capabilities. You need to be able to transfer these hydroxide ions efficiently, and you need to be able to re-oxidize this Mn2O3 up to manganese oxide. And the first part of that technology is covered in Ionic Technologies patent. So if that's the current version of the alkaline cell, what is Ionic Materials' claim to fame? What is it that they are trying to do to improve that? They don't say in the New York Times article at all, nor have Ionic Materials published an academic paper describing their new technology, which makes it rather hard to get details. But you can find their patent published this year, probably why they're now marketing their technology by issuing press releases and talking to the Times. They have a new separator material that's based on a semi-crystalline material, both polymeric and ionic. Pretty interesting hybrid. It is made to contain highly mobile ions, and yet it is also made to be flexible so that it will not be brittle, like the ceramic and glass materials such as those that came out of Dr. Braga's work in the Good Enough lab that got so much great press earlier this year. I got a message in the comments that said, oh, you should not talk about just Good Enough's technology. You know, Good Enough is just really easy to remember. This material that just came out of the Ionic Materials lab is going to potentially be cheaper and easier to make even than that ceramic glass type material, but more importantly, it's going to be, hopefully, if it's everything it's cracked up to be, it will also be flexible and safe and non-flammable. In any event, if you like hearing about new batteries, new battery technologies, how they work, how they are special, tune in Monday through Friday. We talk about science, batteries, research, and building our own batteries here in the Allen Lab.